Hi, in this video what I'm going to show you some basic bit masking. So here in MPLAB I have HITECH C compiler selected my tool suite, and I have written this small piece of code where I just have some variable um, in a variable which is an unsigned char, which I've put hexadecimal 55 in. I have a couple of other unsigned chars, not and or and zo, and I also have a mask value which is 0x0f in hexadecimal. So this is a quick piece of program to just show you what happens when we do some masking. All right, just so that you know the operators, notice in this line we have not, and I've used the tilde, which actually does the not operation, the complement operation in C. I have a single ampersand, which does the bitwise AND operation, a pipe, which does the OR operation, and a caret, which does the XOR operation. Okay, so what I'm going to do is I'm going to put a breakpoint right here on the first line. I'm just going to run to that point. Let's see how this is set up. Now, if we look here in the symbols which I've created in the watch window, some val, you'll notice this is 55. Not, this is 2 at the moment, and also all this doesn't I haven't really done anything with those variables just yet. Okay, so to make this a little bit easier for you, what I'm going to do is I'm going to change the properties. I'm also going to change the format into binary so you'll understand what's actually happening. Okay, so right now some val has 55 in it. I'm also going to change this into binary because it might be easier for you to see it. All right, so you get the idea. So 55, you notice that that's 0 1 0 1 0 1 0 1. Go down the road. All right, so what do we think a not operation is going to do? This complement operation, what I'm going to do is going to click on the step over, and we'll notice that the output of the not is 1 0 1 0 1 0 1 0. It's actually each bit in turn gets flipped, and that's literally the usefulness of this complement operator in C. All right, so what do you think is going to happen with the AND, right? So this mask value is 0f in hex, and awesome value we know is 55 or 0 1 0 1 0 1 0 1 in binary. Okay, if you think about what f is, that means it's 4 zeros in front and then 4 ones at the end. Okay, so I'm just going to step so you can take a look at what's going to happen. All right, and gets 5. Well, let's think about it. Initially some val was 55 and now I have 5. What's up with that? Basically I've just gone and I've extracted my bottom digit because of this mask operator, which is 0f. Because when we do an AND, we know that wherever it's 0 will remain 0, and here in my mask all 4 of my upper bits are 0 and all 4 of my bottom bits are all 1. So what happens there is the upper bits all get set to 0. So in the 55, the first 4 bits get set to 0, and the bottom 4 bits come out, which is the 5. So that's the usefulness of the AND operator. The AND operator is an extraction operator. It clears all bits that are where the mask is 0. So here the mask was 0 in the upper part. It cleared all those bits. And where the mask was 1, i.e. that's my 4 bottom bits, it just extracted those bits, i.e. the 5 came through. All right, let's see what the OR does, another useful operator. I'm going to step. Now let's look at what the OR's result is. Now it's 5F. OR, on the other hand, will always set a bit. That is the usefulness of OR. OR sets. No matter what it is, it will set it. So notice we have the 4 lower bits of the mask are all 1s, and therefore I extract an F here. I get all 1s, they're all set. Whereas where the mask was 0, all of those bits remained untouched. So that's the usefulness of the OR operator in masking. What we can do is we can set some bits while leaving the others alone. And we can clear some bits while leaving the others alone. All right, so that leaves us our last but not least, or XOR operator, which I'm going to now step over and see what that comes out as. Okay, here we go. Now we get 5e. Okay, that's interesting. So let's look at that in decimal. Sorry, in binary. All right. So clearly the 5 came through in the upper half, which means that when you XOR mask with a 0, where all the bits are 0, so where your masking bits are 0 for XOR, you leave it alone. But what happened in the bottom part, where all the bits were 1? We noticed that all the bits were flipped. So the usefulness of XOR is that XOR toggles bits. Wherever your mask is 1 for XOR, XOR will toggle the bit. If it was 1, it'll make it 0. If it was 0, it'll make it 1. And if the mask is 0 for XOR, then it'll just leave it alone. Well, there you have it. That's the basics of masking. Just remember, a complement will just flip all the bits regardless. And AND will 0 wherever the mask is 0, and extract wherever the mask is 1. And OR will set all the bits where the mask is 1 and leave alone all the bits where the mask is 0. And XOR will leave alone anything where the mask is 0 and flip all the bits where the mask is 1. That's it. Thanks for watching. Bye.